everyone, welcome to my YouTube channel. In this video, I'll be presenting the technical description of my project MontChoffe. This video focuses on how the website is built internally, including the front-end structure, JavaScript functionality, back-end architecture, database integration, and security mechanisms. I'll be explaining the purpose of each major file and how different components communicate with each other. So now, moving to the project structure. The MontChoffe project follows a modular and organized folder structure, separating front-end assets, page level logic, and backend functionality. The root directory contains the main homepage files such as index.html, script.js, and style.css. All additional pages are stored under the pages folder, where each page has its HTML file, then the linked CSS under the pages-CSS folder, also the JavaScript inside the pages-JS folder. Backend is placed inside a dedicated folder, that is backend folder, which contains models, routes, middleware, environment, variables, and the main server file. This separation ensures clean code organization and scalability. Okay, now coming to the front-end HTML structure. Each page is built using semantic HTML, ensuring readability and accessibility. The header and footer are reused across all the pages using a shared structure controlled by the main page.css and main page.js. Here is it. This avoids duplication and maintains design consistency. Each HTML page follows a clear layout of hero section, content section, and interactive components such as buttons, forms, and models. Pages like products, recipe, and pairings rely on container-based layouts to dynamically inject content using JavaScript. Now talking about the front-end CSS and responsiveness. The styling is handled using custom CSS with separate files for each page to keep styles isolated. The website follows standard responsive breakpoints ranging from mobile screens up to extra large displays. So total we have like 6 layers of screen sizes. Media queries are used to adjust layouts, font sizes, navigation behavior, and grid structures. For example, the navigation bar switches to hamburger menu on smaller screens, and product cards rearrange from grid layouts to stacked layouts on mobile devices. So for that, in the HTML file, we have made the hamburgers, which is like only visible to the user when the header is scrolled. When the page is scrolled, so the header gets shrink. And then that's styled using the CSS. So for that, we have used the main page.css, where it shows all the information, but once the header is shrink, then it will show the hamburger. Here's the JavaScript code. So yeah, this is the example. That's like the navigation bar switches to a hamburger menu on smaller screens, and product cards rearrange from grid layouts to stacked layouts on mobile devices. Now talking about the front-end JavaScript architecture. JavaScript is responsible for interactivity, DOM manipulation, and data handling across the website. Each page has its own JavaScript file such as product.js, recipes.js, pairings.js, which improves maintainability. Shared functionality like header behavior, authentication, status, and cart updates are handled in common scripts. JavaScript is extensively used for filtering contents, opening models, validating forms, handling buttons, then updating UI elements dynamically without page reloads. Now talking about the login. The login system is implemented using a front-end back-end authentication flow. When a user submits the login or sign-up form, JavaScript sends a post request to the back-end authentication. So here is the login.js. The backend verifies credentials and returns a JWT token, which is stored securely in local storage. This token is then attached to protected request and used to identify logged in users. Based on login status, the UI dynamically updates elements such as greetings and restricted access pages. Now coming to the products page. Product data is managed using JavaScript. When a user clicks the Add to Cart button, the product details are stored inside the local storage, allowing the cart to persist even after page reloads. The cart icon dynamically updates based on the number of items stored. Quantity updates and cart removals are handled by modifying the local storage object and re-rendering the UI accordingly. Then coming to the recipes and pairing. The recipes and pairing pages rely heavily on dynamic rendering. JavaScript loops through structured data to generate cards programmatically, making the system scalable. Filter buttons use event listeners to show or hide content without reloading the page. The recipe models are controlled using JavaScript to inject data such as ingredients, instructions, and linked products dynamically. Come to the form validation and user input handling. All forms, including contactors and carriers, use client-side validation to improve user experience. JavaScript checks for empty fields, correct email formats, and file size limit before submission. Error and success messages are displayed dynamically, ensuring clear feedback without unnecessary server calls. Now, if we look at the admin panel, the admin panel is protected using authentication middleware. Only users with valid admin credentials can access admin routes. Once authenticated, the admin can view order data fetched directly from the database. This separation ensures normal users cannot access the sensitive order management features. Now, coming to the backend. The backend is built using Node.js, Express, and MongoDB. The server connects to MongoDB using a connection string stored securely inside the .env file. The backend includes routes for authentication, order creation, and admin functions. The middleware is used to verify user tokens, ensuring secure access to protected routes. User and order data are stored in MongoDB using Mongo's models, which define the schema and structure of the database collection. The server.js file initializes the Express server, connects to database, and registers all routes. Authentication routes handle login and sign up logic. Order routes management, order creation and retrieval, and admin routes provide restricted access. The auth middleware.js file checks the JWT tokens before allowing access to protected APIs, enforcing security across the backend. Now, talking about the backend front-end integration, the frontend communicates with the backend using RESTful APIs. JavaScript uses fetch requests to send and receive data such as login credentials and order information. Responses are handled asynchronously, allowing smooth integration without page reloads. The integration enables real-time data flow between the user interface and the database. Now, talking about the security and data management, the sensitive data such as database credentials are stored in the env file, that is the environment variables. JWT authentication ensures secure user sessions, while middleware prevents unauthorized access. Data validation on both front-end and backend improves reliability and prevent invalid submissions. So, to conclude the video, MontChoffe is a full-stack web application that integrates structured front-end element with a secure backend architecture. The project demonstrates the proper separation of concerns: responsive design, authentication, dynamic content rendering, database management, and admin control. This technical design ensures scalability, maintainability, and real-world usability. I know you had to see all the codes, but then because of the time limit, we had to adjust the code explanation. So that's it for the video. Thank you for watching.